Hello, beautiful people, and welcome. In today's video, I'm going to go through some of the questions for the Chapter 3 practice exam. Now, reminder, these are not all of the questions that are going to be on the test. This is just a sum of the questions. Chapter 3 is a two-part exam. I'm also not going to be doing all of the questions, although I will be providing majority of the answers. So for your homework submission, if you can please make sure to show all of your work. No work, no credit. All right, let's go ahead and get started. When you're being asked to simplify, you're going to be adding and subtracting here. Notice that we have a minus and a minus in front of two polynomials here, many terms. So we need to distribute that minus. We're not going to touch this first one because it doesn't have a minus in front of it. So we're going to keep it the same. So what we have here is 8b plus 6b cubed plus 4 minus 3b to the fourth and negative 1 positive 5b squared negative b to the fourth and negative 6b negative 6 positive 4b cubed and a negative 7b squared. Okay. After you distribute that minus, you're going to go ahead and combine like terms. Combining like terms can look different. You can rearrange them. Sometimes what I like to do is I like to write them like this. So for example, I take 8b, so I'm going to write it off to the side. So here's 8b, cross that out. I have 6b cubed. I'm going to write that in a different row. I have 4, writing that in a different row. I have a negative 3b to the fourth, writing that in a different row. So these are all different terms. I have a negative 1. I'm going to write that next to 4. I have a 5b squared. That gets its own row. I get a negative b to the fourth, negative b to the fourth. A negative 6b, negative 6b. A negative 6. Make your b's a little boxy. Make your 6's a little twirly here. 4b cubed, positive 4b cubed. And a negative 7b squared, negative 7b squared. So if you have a letter, that letter stays. So I have a b cubed. I have no letter here. I have a b to the fourth, and I have a b squared. Then you're going to pick up a calculator and do the numbers for it. For example, 8 minus 6, it's just 2. 6 plus 4, that's 10. 4 minus 1 minus 6, we get negative 3, constant here. Negative 3 and minus 1. Be careful here, you do have a 1, which is negative 4. 5 minus 7, which is negative 2. This is your work. This is not the answer. So to write out your answer, you're going to write them in standard form. So highest exponent goes first. So negative 4b to the fourth power, then a positive 10b cubed, then a negative 2b squared. Then we have a positive 2b and a negative 3. Question number 2 is asking you to divide. Now, if you take a look here, there is some typos. It looks like the computer did not register my exponents, but it should be self-explanatory when I have a caret and a 3, a caret and a 4, caret and a 2. My next issue is that these are not in standard form. So whenever you do division, they have to be in standard form in order to divide. So as I fix my mistake, I'm also going to be rewriting these. I'm going to be doing long division. Hopefully that gives me enough space. I'm looking for my highest exponent. I got a 3, I got a 4, I got a 2. So 4 is my highest exponent. Then goes 3. Then goes 2. Then goes 1. And then goes 0. If there are any missing terms, we would put a placeholder of 0. Next, you do need to rearrange this in standard form as well. So we're going to write 7n positive and then a positive 5. Okay, to divide, you're going to be taking your, hopefully this is enough space. If not, we can use some scratch paper. We're going to be taking our inside, what we are dividing, this 7x to the 4th power, and then we're going to be dividing by our divisor, leading term here, 7n. So we get 1 over 1, so that's going to be x to the 3rd power. I'm going to write x to the 3rd power here twice. I'm going to be dividing and then multiplying. So we got x to the 3rd power times 7n. Hold on a second. Oh, there's more than one typo. So we have a choice to make. This is wrong. This is for sure a typo. They need to have matching variables. So I have a choice. I either can change these all into n's, or I can change this into an x, which is what I'm going to do. So my apologies here. I'm going to go ahead and cross this out. 5 plus 7x, which I'm going to change that into an x. And I'm going to change this into an x. So my apologies for that mistake here. There you go. Which is going to now be much better. So 7x plus 5, distribute. We get 7x to the 4th power plus 5x cubed. 7x to the 4th power plus 5x cubed. Remember, this is where you need to be a little extra with changing your sign. This is a minus. I'm going to scribble that out, make that a minus as well. And if you've done this step correctly, your terms will cancel out, subtract out here, add, and then we continue. We got 68, and so adding a negative 5, we get 63. Bring down the next term. We're going to continue this pattern. Now I'm going to use 63x divided by 7x cubed. So we get 63 divided by 7, which is 9. 3 minus 1 is 2. So this pattern is going to continue multiple times. 9 times 5 is 45. Copy and paste that. Again, be extra with your sign changes. So here's a minus. Scribble that out. Here's a minus. These are going to be removed. And we get 49 negative. Bring down the next term. And then so we had a positive 9x squared and negative 7x. Multiply that with 7x plus 5. Should be a minus since we have a negative. Okay. And then we're going to change this here. Make this into a plus, make this into a plus. These are going to be removed. 35 plus 35, I get 70 positive. Bring down the 53. And one last round. And again, be extra with your sign changes. 53 minus 50, I get 3. Okay, remember, this is not your answer. We do need to write your answer. And then just for space, I am going to use this B section for our answer. Or maybe I can make it work here. Yeah, I'll try to make it work here. X cubed plus 9x squared minus 7x plus 10 is not your answer. And the reason it's not your answer is because you do have a remainder here, this 3. So we are going to write and. So this is in English, and. We have 3 as our remainder. And then we need to use our divisor, which is this entire thing. Now, if you look at an answer key on any of our questions, they use the original. Now, because there's so many typos, don't worry about that. Go ahead and use the one you're actually dividing by. So 7x plus 5 here. So make sure you have that remainder. If your fraction, so this right here, if your fraction could be simplified with a GCF, go and pull out that GCF and then simplify your fraction like that. We're going to go ahead and fix this typo. Instead of an N, we're going to put in an X here. And the question is asking, is this a factor? Yes or no? Explain. So the reason is no, 5 plus 7x is not a factor. And the reason is this right here. And that is there is a remainder when dividing. Okay, moving on. Okay, this one's asking us to factor completely. I see a binomial. 8 and 125 do not get along. And I see a plus. So that means we are looking at a cubic pattern. So I'm going to take a cube root of 8, cube root of x cubed, cube root of 125. I get 2x as my a value. I get 5 as my b value. And this again, this is just the check for the pattern. And then you actually have to memorize the pattern. A, b, a squared, a, b, b squared. And then for our signs, it's always same, always different, always positive. So I'm taking a look here at this positive, always same, always different, and then always positive. We're going to go ahead and simplify expand. So we're going to expand first. That 2 gets an exponent of 2. That x gets an exponent of 2. 5 times 2 is 10. 5 squared is 25. And then one last time, 2x plus 5. 4x squared minus 10x plus 25. Remember, your trinomial from a cubic pattern will not be able to factor. This one is linear, so we're done. Moving on here, I see a trinomial. We're going to see if there's a GCF. And I do see x, x, and x. So it looks like yes, at least we have x's as a GCF. I see 5, 16. So 5 and 16 do not get along. So we only have a GCF of x squared that we need to divide out. Remember, we're subtracting, so we got 5x to the 4th minus 16x squared minus 16. This is a quadratic pattern of a trinomial because we have a 2. 2 times 2 is 4, so that's our check. We do have a trinomial with the leading coefficient that's not 1, so we're going to use the rainbow method. I'm going to pick up this 5 in a cloud. I'm going to drag it over and multiply it with 16. So we got x to the 4th minus 16x squared. 16 times 5 is 80. We want to multiply to a negative 80 and add up to a negative 16 with our guess and check. Now remember, the trick here is you're always going to take this middle variable in the exponent. And then we're going to do our guess and check. So to do guess and check, you're going to type in the number you need to multiply to, so 80. And I'm going to start with guessing with 2. I'm going to add, subtract these numbers. So 2 plus 40 is not 16. 40 minus 2 is not 16. I'm going to go up. 3, that's not a pretty number. 4, okay, does that give us 16? Yes. 20 minus 4 is 16. So that means I have found my factors. I have 16 and 4. I need to add to a negative, so that means 16 needs to be negative, 4 needs to be positive. Now remember, this doesn't actually exist. This is part of your rainbow method. Because you multiplied by 5, we have to divide by 5. Simplify your fraction if you can. If you cannot, also okay, things happen. And so let's see what we have. Okay, let's go ahead and do this. We got x squared minus 16. 16, why did I write 16? Oh, I see. I'm like, something's not right. Should be 20. I wrote the wrong number. 20 right here. 20. There we go. That's better. So 20 divided by 5 is 4. That works. And then x squared, we get 5x squared plus 4. Now this one right here, take a look. We do have a minus, and we can take a square root, so we can continue with the difference of squares. We're going to take the square root of x squared. We're going to take the square root of 4. Yes, you must have a minus. That means our a value is x, our b value is 2. We continue to factor as x plus 2, x minus 2. Here, we have a plus with an exponent of 2, which means we are done. We are unable to factor that further. These are my factors. Okay, moving on to C. C is always something that gives us a little bit of trouble because it could be a cubic pattern. It also could be a quadratic pattern. That is a binomial difference of squares. So because we do have a minus here, we're always going to do a square root before we do a cube root. So we're going to take a square root. I'm noticing I have a binomial with a minus. Yes, I can take the square root, so we're going to do that. That means your a value is x cubed divided by 2. Square root of 64 is 8. And again, this is the difference of squares. So x cubed plus 8, x cubed minus 8. Now this is not done because now after you've done your difference of squares, both are cubic. So we go into our cubic pattern. I am going to simply write out the answer just because of space, and then you should know your cubic pattern already. So for our answer, we get x minus 2, x squared plus 2x plus 4, x plus 2, x squared minus 2x plus 4. So almost the same, but definitely different with the pluses and minuses. Be careful here. Factor and solve must use the rational root theorem when applicable. So, okay, so what that means is we don't know if we need to use the rational root theorem. That's the silly snake. If yes, we need to, go ahead and do it. If you can cheat and factor, right? If we can do step number 1 and factor, then do that instead. So I see a quadrinomial. I see 4 terms. We need to first check for GCF. I see a 5, a 9, a 3, and a 1. So because of this 1, immediately we know it's not going to be able to factor anything. Next, we're going to check. I have an x, 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 and no x. That means I don't have any variables that I need to remove, and I can't remove any numerical GCFs. No GCF. So then we're going to try grouping. So I'm going to group these two, and I'm going to group the last two. So if I was to remove my GCF of x squared, I'm left with 5x plus 9. Here, the only GCF I have is 1. And we can see that these do not match. These are different. And what that means is it's not factorable with our patterns. So we cannot factor, so we move on to the rational root theorem, which is step number 2. I'm going to take my tail and I'm going to place it over my head. So I get 1 over 5. Factors of 1 is plus or minus 1. Factors of 5 are 1 and 5. Every single numerator gets every single denominator. So I get 1 over 1 and I get 1 over 5. Simplify, remove any repeats. I get 1 plus or minus, and I get plus or minus 1/5. These right here are called possible roots. These are not actual. They could work. They also could not work. So we'll see. Step number 3, we're going to check and see which ones actually give us the zeros. So we're going to open up for x, and I'm going to try positive 1. Let's try negative 1 first, just because then it's easier. Oops, it's easier for me to delete the negative. Plus 9, open up for negative 1 squared, plus 3, open up for negative 1 minus 1. Oh, that actually works. That's great. So we're going to write in negative 1. Negative 1 does give us 0. Step number 4, you're going to move on to synthetic division, writing in that negative 1 here as your x value. Keep track of that, please. 3, 2, 1, 0. Make sure that if you have any missing terms, you put in 0 as a placeholder. Here, how you know that you have the correct root is if you have 0 as the remainder. So here we have 0. That means we're good. We're going to work backwards. Here's your remainder. Here's exponent of 0, exponent of 1, exponent of 2. Step number 5, you're going to write out your quotient. 5x squared plus 4x minus 1, no remainder. Step 6, we're going to go round 2, and that is try to factor. I see a trinomial with a leading coefficient that's not 1. No GCF on that one. Remember, on this step, you won't get a GCF. If you've done it correctly as step number 1 and removed GCFs, if you do end up with a GCF here, that's because your root was a fraction. And then again, we've already accounted for that, so you still wouldn't have a GCF. Your A value is not 1. So we're going to use rainbow method, multiply 5 and 1 together, guess and check. Two numbers that multiply to a negative 5 but add up to a positive 4. So 5 and negative 1. Remember, this does not exist, so we have to divide by what we multiplied. We multiplied by 5, so we're dividing by 5. Simplify when you can. So we got x plus 1 and 5x minus 1. Okay, put that in a thinking bubble. The issue always comes up as to how to write the answer. It is asking you to factor and solve. So for our answer, we got factors, we got roots. We're going to start off with the first step in round 1. Notice that we had no GCF. If we did have a GCF, that's where our first factor would come from. Next, we're going to go to step number 3. Step number 3 was this step here where we had a root of negative 1. We're going to draw an arrow up. That means I have a factor of x plus 1, opposite of what we see. Next, I had 2 other factors here in round 2, step 1. And in round 2, I had a factor of x plus 1, draw an arrow down, which means I have a negative 1. And then I had 5x minus 1, draw an arrow down, set that equal to 0, solved. So we would have a positive 1/5 as a root. Okay, now this right here is not fully correct answer. So I'm going to cross that out and write it one more time. The reason it's not correct is because we have multiplicities. Notice that we have x plus 1 twice, so I have to condense that with an exponent of 2. 5x minus 1. That means our roots have multiplicities, so I have negative 1 multiplicity of 2, and I have positive 1/5. This is my answer. Make sure that if you have multiplicities, that you identify multiplicities. That changes your behavior at that 0. Okay, moving on. Okay, it's still asking us to factor and solve, so we're going to continue. So what do I see? I see a trinomial. Leading coefficient is 1, so that means numerically we are not going to have a GCF. That's a number. I have an x, no x, so that means no GCF. I do see a leading coefficient that is 1, so that means I'm going to use guess and check. Two numbers that multiply to a 56 but add up to a -1. And I get 7 and 8. Again, the trick here, always take the middle variable with an exponent. I need to add up to a negative, so that means I am going to have the negative on 8, the positive on 7. This is just guess and check, so there's nothing to divide by. And then we're going to take a look here and see if there's anything for us to continue factoring because we don't have linears. Now this one has an exponent of 2. I cannot take the square root of 8, so this one's done. This one has an exponent of 2, but I cannot take a square root of 7. And it's a plus, so that fails as well. So this one's done. Okay, so I'm going to start writing our answers. They want factors. So we only have 2 factors, x squared minus 8, x squared plus 7. Those are our factors. Now for our roots, I need to set each one of these factors equal to 0 and solve. So I'm going to add 8 to both sides. X squared, here's 8. So I need to take the square root. Remember, when you take the square root, it's very important. Anytime you have I or a square root, you do have conjugates, so you do have pluses and minuses. X is equal to plus or minus. Now we do need to simplify our radicals, so I'm going to split 8 up into the square root of 4 times the square root of 2. So that means we have x is equal to plus or minus. Square root of 4 is 2, root 2. So that's 2 of my answers. Plus or minus 2 times the square root of 2, comma. Let's do the same thing for the other one. Subtract 7, x squared, -7, take the square root. Remember, plus or minus always appears the moment you take the square root. Now this one, again, we do need to split up, but this time I'm splitting it up as -1 square rooted times square root of 7, which we should note that a square root of -1 is I, and then we have square root of 7. So my second root is plus or minus I square root of 7. These are my answers. Okay, moving on to the next one. This one here, again, no GCF. I'm looking at the leading coefficient of 1. Typically, numerically, if there's a leading coefficient of 1 or any small number like 1, then it's not going to have a numeric GCF. I am noticing that it is a cubic because, yes, I can take a cube root of x cubed. It is a binomial. And I can take a cube root of 125. So A is x, B is 5. You should know the pattern. A, B, A squared, A, B, B squared. Always same, always different, always positive on your symbols. And then expand, simplify. So x minus 5, close it. X squared plus 5x plus 25. And again, we're checking for further factoring. Don't just stop here. So this one here, if it doesn't work on the factoring, then you have to continue using the rational root theorem. If it does work on the factoring, that's fantastic. Continue to solve. So for our answers, we already have our factors. I have linear x minus 5, and then I have a trinomial from a cubic pattern, which does not factor. So we're just going to write these out. I'm going to see if I can make this work. Okay, now it is also asking us to solve, so we need to find our roots. We're going to set each one equal to 0 and solve. And notice I am setting a trinomial equal to 0. So this one is a binomial. We're just going to add 5 to both sides. Here's our root. First one is 5. And then this one here, because it is a trinomial set equal to 0, you have to use the quadratic formula. Quadratic formula is not going to be provided to you. It is something you need to have memorized. Identify your A's, your B's, and your C's. Make sure you take the symbol with it. So negative b plus or minus the square root of b squared minus 4ac all over 2a. And when you're doing this, you're going to evaluate the discriminant first and see if you need to simplify this by hand. Sometimes you do. Sometimes they'll give you things like I. And if that's the case, then your calculator is going to tell you that there's going to be an error and it won't solve it for you. So always do the inside of the radical without the radical first. So I'm not typing in a square root. I'm just typing in the inside. And I see a negative 75. When we see that negative 75, that means two things. I is going to be involved, and we need to simplify 75. So I'm going to write negative 5 plus or minus I. No, let's not do that first. Let's go ahead and write that negative 75 first, and then we can do that in our next step. I'm going to erase this just for more space. If you're using pen, please don't use pen. Okay, close that up, and we have 2 in the denominator. Okay, so what I mean by separating this out, we're going to focus on here, the square root of negative 75. I know I have a negative 1 in here that I can split up, but I also know 75 divided by 25 is 3. So I'm going to separate this out into 25 and 3. Which means that I can once again separate this out as negative 5 plus or minus I. This is I, this is 5, so I'm going to write 5I, order does matter, divided by 2. Now, if you can simplify it more, you must simplify it more. Here's your check. If you were to separate this out into 2 separate fractions with the same denominator, your check is for these. If we can simplify them outside with outside, then you must simplify. If you cannot, then just leave it like this. So my secondary root is going to be conjugates. Again, plus or minus, because I have a radical involved, and I have I. And this is my answer. Okay. Moving on to question number 4. Yes, once again, the computer did not recognize my exponent, so let's go ahead and rewrite that. So we have f of x is equal to 2x cubed minus 7x squared plus 7x minus 2. Now, as I'm writing this, I am noticing I do not have a GCF. It is 4 terms. X, 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 no X. 2 and 7 don't get along. And then I have 7 and 2. Now, I can try to do grouping. I already know that if I put these into groups, I have 2 and 7, 7 and 2. That's not the same thing. So step 1 fails. I cannot factor. That means I have to move on to step number 2, which is the rational root theorem, and find out which possible roots I have. Got to write smaller on this one, please. Every single numerator gets every single denominator. Simplify here. This is just 1. I already have a 1. This is 2. So my possible roots are 1, 1/2, and 2, plus or minus all of them. Step number 3, I'm going to open up for x, and I'm going to try -1 first. The reason I like to try -1 first is because it's easier for me to go back and just delete the negative instead of inserting a negative. So -1 did not work, so I'm going to go back and delete the negative. One positive does work. Step number 4, we're going to do our synthetic division. 3, 2, 1, 0. Make sure there's no missing exponents here. Make sure you also take the sign. So we have a -7 and we have a +7 and a -2. Bring down the 2, multiply. And again, you must have a remainder of 0. If you don't have a remainder of 0, that means a mistake has occurred. Here's your remainder. Here's your exponent of 0, of 1, and of 2. You're going to write out your quotient. Writing out your quotient, you have 2x squared minus 5x plus 2. And step number 6, you're going to try to factor one more time. We do have a trinomial with a leading coefficient that is not 1, so we're going to do rainbow method. Looks like, yes, we can factor further and say we have 4 negative and 1 negative. Again, this is not true. This is not what you have. You need to, since we multiplied by 2, we need to divide by 2. So our factors are x minus 2 and 2x minus 1. Okay, so a few things. First thing we need to do is we need to write our factors and we need to write our roots. I'm going to use some space here. Step number 1, GCF. Did I have a GCF? No, I couldn't factor. There was no GCF. Step number 3, I had my first root of 1, so my factor is x minus 1. Then I moved on to step number 6. I had 2 other factors of x minus 2, which gives me a root of plus 2. And I had a factor of 2x minus 1, which gives me a root of a positive 1/2. Okay, now that we have our roots, we can identify them on the graph. So here's 1, here's 2, and here's 1/2. So all of them are positive. I'm going to actually erase and make it a little bit more spread out. So 2 can be here, 1 can be here, and so 1/2 can be here. Okay, now that we're here, we are going to identify our end behavior. So as we go to the right, and then as we go to the left. Looking for our end behavior, we're looking at our total degree. Total degree is 3, and that comes from our original exponent. The original equation, highest exponent. That means this is odd. Leading coefficient was 2, which was positive. Positive means we're going up. Odd means we have a John Travolta style. So it's not going to be John Travolta, but it's going to be a style. That means on my left-hand side, I'm going down. And on my right-hand side, I'm going up. Okay. We're going to wait for the y-intercept. So here we're going to go right hand going up, left hand going down. You must give me infinities. This is just shorthand. So we're going to write arrow. Okay. At 1/2. So take a look at your exponents. I have linear, linear, linear. So we're going to go and create our behavior going straight through. At 1, we're going straight through, and at 2, we're going straight through and connect. So how do we know what the behaviors are? The behaviors are coming from the exponents on your factored form. So I have a 1, a 1, a 1. That means this is going to be a line, and a line. To find the y-intercept, you're going to open up the original. And I already have the original typed in. And I'm going to go in and I'm going to replace my 1 that I checked in step number 3 with a 0. So all of my x values are 0. And I get a y value of -2. Okay, almost done. We're going to be graphing a cubic. Make sure that if you see a b value, you're going to factor that out. So we get -3 open, 1/2 open, cubed plus 2. And how to do that is you're going to take that inside and you're going to divide by that b value. Make sure if you're using a calculator that you are putting parentheses around that. So open 1/2 divided by open 1/2, that should give you 1. And then 4 divided by open 1/2 gives you 8. This gives you your h value. This gives you your k value. This is opposite. This is keep. So we get our point of inflection. Point of inflection is going to be a positive 8, 2. T-chart, write your point of inflection in the middle. And now you're going to find pretty points. So 7, 6, 5, 9, 10, 11. You're going to find some pretty points on the curve. You're going to start with the original. Now be careful here because you do have a fraction. So what you need to type into the calculator is -3, open, open 1/2, close it, times your x value -4, close it, caret 3 plus 2. -3, open, open 1/2, close it, times. Now I'm going to try 7 -4, close it, caret 3 plus 2. 7 gives me a decimal. 7 is not good. I'm going to go up, go over, replace that 7 with a 6. 6 does work. I'm going to keep track of my point of inflection. I'm going to move my 6 into a 9. 9 does not work. I'm going to make my 9 into a 10. And I get a -1. So I have my 3 points. Please make sure to keep track of your point of inflection. That is important. So 5, 6, 7, 8. Be careful here. 1, 2, 3, 4, 5, 6, 7, 8 is here. Please make sure to count. And then we have 2. This is your point of inflection. Then I have 6 and 5. 1, 2, 3, 4, 5. I have 10, which is almost off of the page here. And then -1. Put your pencil on your point of inflection, curve down, and then curve up. Should look something like this. There should be no point here. Smooth curve. All right. Question number 6, we have 2. Write the polynomial function of least degree with integral coefficients that has the given 0. So we're assuming a is 1. It is asking you for expanded form, so standard form. This is where you're going to create a small little table in the beginning, and you're going to have your roots. You're going to have your pattern for your factors, and then you're going to have your multiplicities. Now, we have a -5 as a root. That means I'm going to put in -5 inside here. And then I have a multiplicity of 1. How do I know I have a multiplicity of 1? And that is because it's not giving you a multiplicity. If they're not giving you a multiplicity, there is no multiplicity. That means your exponent is 1. Now here is an alert. Because I have a 3 negative plus a square root of 3, that means it comes with -3 minus square root of 3. These are conjugates, and we must have them in pairs. You can't have one without the other. So for my pattern, I get x minus open, -3 plus the square root of 3, close it. And then x minus open, -3 minus the square root of 3. So we're not going inside of the radical, but this minus does need to be distributed. And again, since they're not telling us multiplicities, the multiplicity is 1. So we have our factored form. Factored form are going to be these right here. So we have x plus 5, close, x plus 3 minus square root of 3, close, x plus 3 plus square root of 3. Now, these are factors. They don't want it in factored form. They want it in standard expanded form. So that means you need to multiply out. You must multiply conjugates together. You cannot multiply these two together, okay? Only conjugates get multiplied first. You're going to go ahead and do a box method for your ordered thoughts. Okay, be careful of signs. Add the exponents together. Don't go inside of the house. We can't go inside to 3. So the x is on the outside. Oops, 9. And we're here. Okay, be careful here. We have inside with inside. We have a negative. And then 3 times 3 is 9, which, yes, we can simplify that 9. So we have negative 3 here. Be careful. Okay, so what's the point of us multiplying the conjugates together? Well, the whole point is to remove things like square roots and i's. So here's a negative x root 3. Here's a positive x root 3. These are gone. Here's a negative 3 root 3. Here's a positive 3 root 3. It's gone. And so what you're going to notice is we have, I'm going to bring that down. Now we have x plus 5 times x squared, add these together, plus 6x. 9 minus 3 is a positive 6. Now you're not done. You still need to multiply these. Again, box method. And then you can write out your answer, which I'm going to do for you. So make sure you multiply this on your own. Please do not just copy the answer without showing me work. So the actual answer is x cubed plus 11x squared plus 36x plus 30. It is asking you to write a polynomial function, so p of x must be there. Okay. Last one, expanding. So for expansion, this is talking about Pascal's triangle. This is going to be your row number. So we're going to write out 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Our row number is 5, so we want the 1, 5, 10, 10, 5, 1. So how do you know the row number? Well, it's the second number you write out. Next, you're going to write these out. I have, let's see where I have space. I have 1, 5, 10, 10, 5, 1. You're going to write 2 parentheses. I might not have space on this one. Starting with the first parentheses, I'm going to move this 1 and this 5. Starting with the first parentheses, we're going to take our row number 5 and work our way down 4, 3, 2, 1, 0. Working our way up now from our row number 5, 4, 3, 2, 1, 0. In the first parenthesis, in the first bubble, we're going to write out our first term, and that is 3x to the 4th power. And then our second term here, be careful. This is a negative 1. And then you're going to expand. Okay, just for space, I won't be able to do the top ones that I don't want to erase, but I'm going to show you here how to expand. So we would have 1 times 3 raised to the power of 0. X to the fourth raised to the power of 0 means you're actually multiplying those exponents together. Okay, so you're bringing that 0 onto 4 and you're bringing that 0 onto 3 times -1 to the fifth power. I'm going to expand this one more time. 5 times 3 to the first power, x to the fourth power times 1. So 1 goes on 4, 1 goes on 3. And again, expanding that one more time. 10 times 3 to the second power, x 4 times 2, -1 cubed. 10, 3 to the third power. Make sure 3 is in parentheses, and then the exponent is on the outside. Versus on 4x, we're just multiplying 4 times 3 together here. And so here I'm just going to put a dot, 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 dot. After you expand, this right here is your work. This one goes here. Okay, so all of that's your work. So that's not your answer. Your answer needs to be written in standard form. Now, standard form means you are unable to rearrange anything. So please do not rearrange. If you rearrange these right here, then your A's and B's are not going to be the same. And so these are going to be incorrect. Don't rearrange anything. Keep it in order. And so now we are ready to write our answer after you show me work, because my work's not done. So we have 243x to the 20th power minus 405x to the 16th power plus 270x to the 12th power minus 90x to the 8th power plus 15x to the 4th power minus 1. This here is your expansion. You must show work. Okay? All right, beautiful people, that is it. Thank you so much for watching. Take care.